So we need to find the equation in standard form of an ellipse that has foci here and here, and it has a major axis that is 6 units long. So let's just stop and think about it. Let's read the problem again very slowly, very carefully. Part of knowing how to do this is knowing how to problem solve and read the problem carefully. So, find the standard form. Stop right there. Find the standard form of what? An ellipse? Yes. So let's write down the standard form of an ellipse and think about what we need in order to really do this. So up here in the corner, we're going to write the standard form of an ellipse. Now, of course, there are 2 different forms, but we'll be okay. We'll just go ahead and write this one. And I'll tell you why this one is the correct one in just a second. Okay, this is the standard form of an ellipse. So in order to figure out, and in order to write the standard form, we need to fill in numbers like h, k, a, and b. Now, again, there are 2 different forms of the standard form, and it depends on whether or not the major axis is horizontal or vertical. So we do run the risk of having the wrong one and the a and the b be switched. We'll cross that bridge later. I'll go ahead and tell you this is the right one, but even if you get it wrong, you can easily correct it. So let's just keep going from here, knowing that in just a second we're going to need to find A and B, H and K. And even though it's not in the formula, I'm having a hard time drawing a K here. There we go. Smudged it there. Alright. Even though it's not in the formula, let's put this, because there was a formula that you were just introduced to that involves A, B, and C. So there's a possibility that we'll be able to find 2 of these and use that to get the 3rd one. Or maybe these 2 to get that one. So even though C is not in the formula, we might need it to get some other stuff. So what would really help is having a picture of this. So let's just sketch a graph. It doesn't have to be perfect and it doesn't have to be pretty, but it will kind of help us get a visual. So let's draw it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 1, 2, 3. So we have foci at 0, 1. So here's a point. And at 4, 1. 4, 1. And the foci lie along the major axis. And so knowing that it lies along the major axis, we know that it is wider than it is tall. Okay, let's think about that for a second. Knowing it's wider than it is tall, the major axis is horizontal, so this is the correct form. If the foci were lined up vertically, then it would look like this instead, but it doesn't. It looks like this. It might be flatter, it might be slightly taller, but we know it's of this general shape more so than this one. Okay, let's start looking over here and seeing what we can find. I believe there's an obvious thing to go for first whenever you're finding the equation of an ellipse or a circle or later on hyperbola. So what we need to do first is find the center. That's normally, not always, but normally one of the things we can easily find. And the center is halfway between the 2 focal points, the foci. And so it must be exactly halfway in between those. You can look at your graph and tell where it is, but also I want you to consider that you can easily look at these coordinates and tell where it is. So what's halfway between 0, 1 and 4, 1? Well, take it one component at a time, one coordinate at a time. What's halfway between 0 and 4? Well, that would be 2. What's halfway in between 1 and 1? Well, there is no halfway in between 1 and 1. It's just 1. Basically, the average of 1 and 1 is 1. And again, you can tell from the picture. There it is. There's the center. The center is at 2, 1. So we've already found H and K. Lucky us. So now what we need to find is A and B, and C might come into play here. So the major axis is of length 6. And one of the things that was told to you in the previous video was that the major axis has a length that is 2A. So let's just come over here with a pen and let's write down something. 6 equals 2A. Well, if 6 is 2A, well, obviously we know what A is now. Oh shoot, let's not write it there. Let's just write it here instead. 3. A is 3. Lucky us. All we need now is B. While we're at it too, let's start drawing this ellipse just a little bit better. We know the major axis is 6 units long, so we know that is 4 units long, and therefore it must go 1 unit further in each direction, so it goes out to here and it goes out to there. These are the two vertices. It did not ask for those, but just in case. So it goes something like this, but again, we don't know how tall it goes. We're not quite sure with that yet. But I tell you what we do know. We do know C. Okay? Refer back to the original picture at the top of your notes. You have a focus and the center. And one of the things that was said was that the distance from the center to either of the foci is C. The distance, for what it matters, from the center to a vertex is A. That's 3. The distance from the center to a focus is C. Well, how far is it from our center at 2, 1 to a focus maybe at 4, 1 or maybe at 0, 1? What is this distance right here? I believe you can count. The answer would be 2. There we go. Okay, there was a formula that you got, and it looks almost Pythagorean, but it's not. And here it is. A squared minus b squared equals c squared. And it deals with the a, the b, and the c involved in an ellipse. It is not a right triangle issue. We used right triangles to build to this, but it's not a Pythagorean issue. Okay, but we do know a, we don't know b, and we do know c. So 9 minus b squared equals 4. We can subtract that. Negative b squared is equal to negative 5. Therefore, positive b squared is equal to positive 5. And b is equal to the square root of 5. There we go. We got it. We have a, b, h, and k, and c. We don't need it anymore, but we got c. We have c. So, by the way, I want to point out one thing real quickly down here. When we square rooted, normally it's plus and minus, but we're dealing with distance. Therefore, it's not going to be negative 5, negative square root of 5. What that tells us is this. This length is 3. This length is the square root of 5, and the square root of 5 is 2 and some change. So it goes up 2 and just a little more. It goes down 2 and just a little more. And it's shaped kind of like this. Looks a little bit like a football the way I've drawn it. There we go. There it is. That's what it looks like. Now, we're not quite done. Let's put the final answer. I'm going to squeeze it in this open space down here. The final answer is standard form. This, with these numbers filled in. So it is x minus 2 squared over a squared. So it's 9. Some math books, mathematicians, will put actually 3 squared. They won't put 9. They'll put 3 squared just so you can really look at it and know what a is. You know what the square root of 9 is, so we're not going to mess with that. Alright, y minus 1 over the square root of 5 squared, which would simply be 5, and that is equal to 1. Here it is in red. There's our final answer. Okay? For the next problem, it's going to take us on a slightly different route. What we're going to do instead is sketch the graph in the end, but we're going to have to get the equation before we can ever sketch the graph. So here we go. I'm going to keep that formula up in the corner. You may want to write it on the next problem. Straighten this thing back up. It gets crooked sometimes. There it goes. So they gave us the equation, and knowing that they gave us the equation, what we'll be able to do now is manipulate that equation until it looks like this thing up here in the corner. So let's get started with it. X squared plus 4y squared plus 6x minus 8y plus 9 is equal to 0. My goodness, Mr. Reader, what in the world are we going to do with that? I'll tell you exactly what we're going to do with that. We're going to make this look like that. First thing I notice, it better equal 1. When we're done, it's going to equal 1. Right now, clearly it does not. That's going to be one of the last things we do. Let's start the problem, and this is going to start looking like some of the circle stuff that you've already done. Let's group the x's together, and let's group the y's together. X squared plus 6x. I know you're tempted to put plus blank, but let's hold off on that for just a second. I'm going to leave a little gap just because I want to specifically group them separately. Let's put our y's together. And it is equal to -9. That number is more than likely going to get in our way when we're doing computations, so we'll move it over, kind of put it out of the way, not bother with it. Now, again, you're probably tempted to put plus blank, but don't. Now, in this case, it would work with your x's, and actually, let's go ahead and write that. X squared plus 6x plus something, you probably already know what that is. It's 9. However, something crazy happens here, and here's the problem, and this is where ellipses and circles are different in their equations. Ellipses sometimes, very frequently, have a number that would pop up in the front here that has to be factored out. Notice that this is not y squared, it's 4y squared. And so we need to factor out a 4 from all of the y terms. So we're going to factor out the 4. So we do that, we have y squared minus 2y plus blank, and that is equal to -9 plus something plus, now, I'm about to put another blank, but whatever goes in this blank isn't just blank, it's 4 times blank, okay? In just a minute we're going to put a number in this blank. It's the number 1, you know that, I know that, but it's really not just a 1 that we're adding to that side, it's 4 times 1 because there was a 4 in front of the parentheses. Okay, half of that squared is 9. Boom. Half of that squared is +1. There we go. So here's what happens on the right. -9 plus 9 cancels out. They're additive inverses of each other. 4 times 1 is 4. Looking ahead, in the end it better equal 1. Clearly it does not. We'll get there later. Right here we have 4. Y minus 1, and it is squared. And x plus 3, and it is also squared. Now, again, it should equal 1, and it does not, but we can very easily make it equal 1. Let's do something to turn this side into a 1. Let's divide. What would you divide by to turn this side into a 1? 4. I hope you were thinking of the number 4. Here it goes. Anything divided by itself is 1, with the exception of 0. No one knows what 0 divided by 0 is. There we go. So now what we have is 4 over 4, which is 1. These 4's cancel out. Divide out y minus 1 squared. And just to make it look like this, it's over 1. And that's over 4. Okay. We're going to take the information we have here and we're going to use it to make a graph. And I think this is the first one we've graphed based on the equation. Also, before we go there, I want to point out one thing. This equation, of course, there are two forms of it. This would be if the major axis is horizontal, because A is bigger than B in these equations, and A is underneath the X, so this one better be wider than it is long if this is truly consistent with this. And it is. A is bigger than B. Whenever we draw this, it's going to be wider than it is tall. Okay, let's draw it. 1, 2, 3, 4, 5. 1, 2, 3 should be enough. 1, 2, 3 should be enough. There. Okay. The center. I'm going to write some stuff down. Let's put it in green. The center is at -3, +1. A is the distance from the center to the vertices, if it's horizontal this way, or center to the vertices if it has a major axis that's vertical. Again, this one is wider than it is tall, so this is going to be the distance from the center to the edge, and it's the square root of that, so it better be 2. And B is the square root of that, so it's 1. How are we going to take that information and draw a graph? I'll show you. Now, our foci are not going to appear on this graph. But we do know the center is at negative 3, 1. We do know that A is 2, meaning, again, we are going to go in the x direction, because that's where the 2 came from, square root of 4. We're going to go in the x direction, 2, either way. 2 to the left, 2 to the right. We will go in the y direction, the square root of 1, which is 1. We're going to go in the y direction, 1. Up 1, down 1. This one is wider than it is tall. There you go. There's your graph.